Welcome back to class. So let us look at the graphical representation of Boyle's law. The graphical representation on Boyle's law, that is, if you are to represent Boyle's law on a graph, how would that graph look like? Now, I have two graphs on the board representing Boyle's law. This is the first graph. Figure 1 is the first graph, while figure 2 is the second graph. Now, if you look at figure 1, you'll see that on the horizontal axis, you have the volume, and on the vertical axis, you have the pressure. Whereas for figure 2, on the horizontal axis, you have the inverse volume, that is 1 over volume. Then on the vertical axis, you still have the pressure. Don't forget that the relationship that exists between pressure and volume as regards Boyle's law is an inverse relationship. That is, Boyle's law is telling us that the higher the pressure, the lower the volume, or the higher the volume, the lower the pressure. So now, how do we graph that? Since we are having an inverse relationship between pressure and volume, it means that this curve will slope downwards like this. This curve will slope downwards. What does that mean? Now let me tell you what it means. And this value, this is the what? This is the highest value of the pressure. This is the highest value of the pressure. If I should trace that, if I should trace that to the curve, if I should trace that, I'm just taking that point as the highest value of pressure. Of course, it can go higher than that. If I trace that to the curve and then trace it down, you would realize that it falls at the lowest value of the volume, or it is falling at the lower part of the volume. Maybe I should give this some figures so that you can see what I'm talking about. Let us give it some figures. Let us say this is 0. This is, let's say, 5, 10, 15, 20, 25, 30, and then 35. And then this one I will go with maybe 2, 0, let's say 2, 4, 6, 8, 10, 12, 14, and so on and so forth. I'm only putting figures there so that you can see what I'm talking about. Now, when the pressure was at 35 millimeter of mercury, just for an example, then the volume was at what? At 2 centimeter cube. That's at 35 millimeter of mercury, we have 2 centimeter cube of gas. Okay, what about if we decrease the volume to 30? What do we have there? If you trace it downwards, it is still somewhat at 2 millimeter cube. Then if you keep decreasing, you'll notice that as you are decreasing the pressure, the volume is increasing. As you are decreasing the pressure, the volume is increasing. So if you keep decreasing like that at 25 mmHg, then your volume is somewhat higher than 2, not exactly on 2, but somewhat higher than 2. At 20 millimeter of mercury, the volume is almost at 4 centimeter cube. At 15 mmHg, trace it down, the volume is above 4. At 10, the volume is around 6. At 5, the volume is around 10, almost 10 centimeter cube. So what does that mean? So this means that the higher the pressure, the lower the volume, or the lower the pressure. In this situation, the lower the pressure, the higher the volume, meaning that as we keep increasing the pressure, the volume keeps decreasing, or as we keep decreasing the pressure, the volume keeps increasing. Now you will notice that this is actually a curve. It is not a straight line. It is not a straight line because it is not a linear relationship. The relationship between pressure and volume as regards to Boyle's law or to the behavior of gases is not linear. If it was linear, it would have been a straight line, just like this. So it would have been a straight line. But if you are plotting pressure against volume, you're not expected to get a straight line. You're supposed to get a curve. By the time you join those points together, you have this curve. So that's for figure 1. Now for figure 2, figure 2 is similar to figure 1, except that we are plotting pressure against 1 over volume. That is, we are taking pressure against 1 over volume. And if you look at this relationship, you will see that the higher the pressure, then the higher the value of 1 over volume. That is, we are taking the inverse of the volume. Let me put some figures here so that you can get what I'm talking about. Let me put some figures here. Again, let us assume that this is 0, 5, 10, 15, 20, 25, 30, 35, 40. It goes on like that, till as many as you can write. Then for this, we have, let's say, now look at this. If I'm taking volume to be 2, then my 1 over volume, that will be 1 over 2. And what is 1 over 2? That should be 0.5. If I'm taking volume to be 4, my 1 over volume should be 1 over 4. And that is what? That is 0.25. So it is decreasing, right? It is decreasing, isn't it? So that will be 0.25. No, I don't want to go this way. I don't want to go this way. Because if you are going towards the right, it should be increasing. The value should be increasing. And if you are coming towards the left, your value should be decreasing. That is how you plot a graph. So let's just, take some random arbitrary values for the volume. You say, okay, our one over volume is, let's say, let's go with 10, 20, 30, 40, 50, 60, and so on and so forth. Now, this is 1 over volume. Don't forget that. This is 1 over volume. If I'm to look for the value of volume itself, okay, let's say I'm looking for the value of the volume at 1 over V equals 10. That means my volume will be 1 over V equals 10. If I should cross multiply, then I have my 1 equals to 10V, and then I have V equals, of course, my V equals to 1 over 10. So that's 1 over 10. That is 1/10 of the volume. So if I should go on like that, I can get the value of V. And if you do that, you will realize that the V is actually decreasing. If this one is 1 over 10, then the other one should be 1 over 20. 1 over 10 is 0.1, by the way. So the other one, 1 over 20, should be 0.0 something. That's a 0.05. So which is less than 0.1. If I keep going like that, you'll see that the volume is actually decreasing. The volume is actually decreasing. But we are taking 1 over the volume. We're taking 1 over the volume. So now, what do I mean by this? Now, let's trace it down. So at the moment where your pressure was 40 millimeter of mercury, 1 over V. Okay, don't let me start with 40. Let me start with 30. And if you trace it down, your 1 over V is somewhere between 40 and 50. That's probably 45. At 35, that's 35 millimeter of mercury. Your volume is almost at 40. This is just to make you understand what is going on. I just took some arbitrary values. Then at 25, your volume is at 30 centimeter cube. At 20 millimeter of mercury, your volume is at somewhere above 20. Now, pressure, I'm taking pressure as millimeter of mercury because the unit of pressure here that I'm using is millimeter of mercury. Millimeter of mercury is written as mmHg, millimeter of mercury. It is a unit of pressure. There are also other units of pressure like Newton per meter squared. There is also Pascal. There is also bar, atmospheric pressure. All those things we're still going to talk about that. And then we'll look at the conversion between one unit of pressure to another unit of pressure later on. Now, at 15, of course, it goes on like that. It goes on like that. So what can we say here? We can say that the relationship between pressure and 1 over V, that is 1 over volume, is a linear relationship. I'll take that again. The relationship between pressure and 1 over volume is a linear relationship. It is a linear relationship. While the relationship between pressure and volume is not a linear relationship. Can I say that the curve is sloped? The curve is coming inwards a little before it goes down. Although it's an inverse relationship, but it's not linear. When I say linear, I'm talking about a straight line. Linear is from the word line, L-I-N-E, line. So if I say linear, I'm talking about a straight line. Like this is a straight line, this is linear. But this one is not linear, this is a curve. This is a curve. So that is the graphical representation of Boyle's law. Now let us look at calculations on Boyle's law. Let us look at this calculation together. Example 1 says, the volume of a given mass of a gas at 10 degrees Celsius and 600 millimeter of mercury is 140 centimeter cube. What will be the volume of the gas at 10 degrees Celsius if the pressure is 1200 millimeter of mercury? Now, first of all, I want you to understand something. In Boyle's law, your temperature is kept constant. Your temperature is kept constant, meaning that your temperature is not changing. Your temperature does not change from one value to another value. Whenever you are increasing the pressure or you are decreasing the pressure, the temperature is the same. Or if you are increasing the volume or decreasing the volume, the temperature still remains the same. So if you look at this question, the 10 degrees Celsius, that is the initial temperature of the gas, was 10 degrees Celsius. The final temperature of the gas is still 10 degrees Celsius. That is after you have done what? What will be the pressure? So the pressure was doubled. Yeah, you have 600 millimeter of mercury. They're now asking you that what will still be the pressure at 1200 millimeter of mercury, meaning you have doubled the pressure, but the temperature did not change. So that means it is safe to say that temperature is kept constant. And this particular question illustrates Boyle's law. It illustrates Boyle's law. Now let's solve the problem together. How do you solve this problem? Let us first of all identify our initial pressure and then the initial volume, as well as the final pressure and the final volume. Let's identify them. The volume of a given mass of a gas at 10 degrees Celsius and 600 millimeter of mercury. This 600 millimeter of mercury is our initial pressure. P1 is equal to 600 millimeter of mercury is 140 centimeter cube. That's our V1. Our V1 is 140 centimeter cube. Then what will be the volume? We are looking for V2. V2 is unknown. We are looking for V2. What will be the volume of the gas at 10 degrees Celsius? I don't need to write the temperature. Why? Because I'm not going to use it. I won't use it in the formula because the formula for Boyle's law is P1 V1 is equal to P2 V2. Temperature is constant, so there's no need to pick the value of temperature. Now, what will be the volume of the gas at 10 degrees Celsius if the pressure is 1200 millimeter of mercury? So our P2 is now 1200 millimeter of mercury. Now, what's the formula I said we are going to apply? What's the formula for Boyle's law? That's P1 V1 is equal to P2 V2. So let's put in those values. My P1 is 600, so I'm going to write 600 times my V1 is 140 is equal to my P2 is 1200 times my V2 is unknown. I'm looking for V2. I may just for the sake of acknowledging that we were given temperature, a constant temperature, I can just acknowledge that my T1 is equal to T2, which is equal to 10 degrees Celsius. That is, the temperature is constant. However, I don't need it in my calculation. Now, from here, what is this going to give me? For me to get V2, what am I supposed to do? I will divide both sides by 1200. This one too divided by 1200, so that this can cancel this. And then what is this going to give me? So I have 0 cancels 0 here, 0 cancels 0 here. 6 goes here is 1, 6 goes in 12 is 2, and 2 goes here 1, 2 goes in 140 is 70. So that means that my V2 is 70 centimeter cube. That's the final answer. And it actually makes sense. It makes sense because the relationship between pressure and volume is inverse relationship. What does that mean? It means that if the pressure was doubled, in this situation the pressure was doubled, if the pressure was doubled, then your volume should be half. Let me take that again. If the pressure was doubled, which means it was increased it was doubled, the pressure was doubled, then the volume should be half of the initial volume. The final volume should be half of the initial volume. Now, what about if the pressure was tripled? If the pressure was tripled, then the volume should be what? The volume should be 1/3. The final volume should be 1/3 of the initial. 1/3 means you divide it by 3. That's the meaning. Because it is an inverse relationship. As one is increasing, the other one is decreasing by the same amount. That's the meaning. As one quantity is increasing, the other one is decreasing, or as the other is increasing, the first one is decreasing by the same amount, because it is an inverse relationship. Alright, so this is where we're going to stop for Boyle's law. I'm still going to solve more questions with you, and this will be the end of this particular video. Bye for now.